Kerry, you got that there? You see
Yeah.
it?
Yeah.
Okay. So guys, session 5. Let's talk about a little bit of chart work. So we'll do a little bit of recap on some of the stuff we spoke about last week on what's on charts and what's available on charts, and then we'll go into some of the bits and pieces that we can use charts for.
I'm sure it's not meant to be. I'm sure it's meant to be compass.
Reiterate a little bit of what we did last week on what we see on a chart, just in case somebody wasn't here. So the yellow piece, the piece above the mean high water spring, that's pretty much going to be your land all the time. The piece that's blue below that is chart datum. Now, chart datum, just as a reminder, is your lowest astronomically recorded tide. So that's as shallow as the water will get. That doesn't mean to say it's going to be what you're in now. That's as shallow as it gets. And then your contour lines, depending on the chart, might be 3, might be 9 meters, might be whatever. That's as a 5 and a 10. It tells you it's a 5 and a 10. You can see the numbers here on the actual contour lines. Okay, we spoke about mean high water spring. The shoreline is the gap between mean high water spring and chart datum. And it might be depicted as such as well. Note the 0 around the 1.2 there. So it doesn't necessarily mean it's going to be green. Okay. Land permanently dry. Okay. And then a drying above chart datum. Again, because it's chart datum, it might well not be dry. The tide might be higher than that. Okay. It gives you a drying height. See the two I've circled at the top here? So that's your drying height. Note that these heights are in brackets, whereas your underwater heights are not in brackets. So if you see a height in brackets or a number in brackets, it means it's a drying height. Okay, drying rock, that says it dries to 1 meter. A rock awash, remember we spoke last week about the cross with the 4 dots, or the star, or the straight cross, a rock below water. Just a little reiteration. Okay. An unconfirmed sounding. It was sounded a while back at 12 meters. That's where it is. And then the dangerous rock, the cross. So I thought it was worth going over this again, just because chart work, obviously that is a really, really major thing, specifically these different land above high water spring, chart datum, the gap between the two, there and there, flooding areas, rocks flooding, rocks awash, rocks below water. Quite important stuff. Okay, so let's go straight into our position of dead reckoning and estimated position. Now people will go like, why do I need to worry about dead reckoning? Okay, dead reckoning is very, very basic navigation. There's you are at 9 o'clock, you're doing a speed of 10 knots, you're going to travel 5 knots, and then another 5 knots. An hour later, you've done that distance and that course and speed. It's very basic navigation, which is incredibly useful. It can tell you immediately if there is something else happening to your boat, if there's leeway, if there's current, if there's any tide, any other influences. So if you plot yourself a dead reckon course, and then you plot exactly what you did, you can make a comparison between the two. I use it all the time. So say your course is 030 degrees true. There you go. There's your hour. There's your speed of 10 knots. Okay. The effect of wind and current and tide are not taken into account on that dead reckoning calculation. You then do that trip and you can end up anywhere. So what happens with the wind? It moves you off course. There's your new estimated course. You've got 10 degrees leeway. There's leeway taken into account. So instead of ending up there, you're going to end up somewhere here where the arrowhead is. Okay? Leeway cannot be forecast accurately. We don't know how big the waves are going to be. We don't know how many gusts are going to hit the boat, etc., etc., etc. It literally is an estimation. Okay? It can, however, be worked out in the past tense. Where did I accurately go? That was my 9:30 mark. There was my 10 o'clock mark. You can then say, with your dead reckoning course, that's where I was pointing. Leeway did that to me. That's how it affected my boat. So your dead reckoning course has just become very useful to see how it's affected you. Okay? That means you can then use it in the next hour's course prediction. Where do you think I'm going to end up? Oh, there. Because you can take into account what you've just learned in the last hour with a dead reckoning and a leeway. Okay? It can obviously vary according to the wind. As I said, it's unpredictable. You notice I've changed the wind angle. That's exactly what will happen to your leeway. You'll be pushed out more leeway as you go closer and closer to the wind. As the wind gets stronger, more leeway, and eventually to the point where you can actually end up going sideways. So leeway is an unpredictable means of navigation. It is the most unpredictable part of navigation. Okay? So when we navigate, we want to be able to fix our position as often as we can. There's loads of techniques. I'm just going to go through a couple here. So a fixed point. A fixed point technique. There's a mark. It's a north cardinal mark. No problem. Okay. We know as we're sailing past that mark, if we look on a chart, we're there at that time. It is the easiest way to fix your position. Sail past something that's on a chart and is accurate. Don't have to look at a GPS, don't have to do a damn thing. You just look at that and go, we're there. We know exactly where we are. That's easy. So go next to a buoy, a harbour wall. If you're caught in fog off Cape Town, and you manage to find a nice big green light off the end of the harbour wall, you've got a fixed point in fog. You can then do a dead reckoning course straight across towards Duncan Dock. But once you've got that fixed point, you know where you are, you can navigate from there. During the exams, we do what we call blind navigation, where the person being examined has to go below and sail between A and B, wherever they are, without being able to look out the window, because he's in blind navigation, he's in fog, or he's in some means of restricted visibility, hypothetically, obviously. And the way we teach it is literally to sail from buoy to buoy to buoy, because that gives you a fixed point every time you get to a buoy. Okay. We can obviously take bearings on other fixed objects. Now, there's a big caveat on this. Are your fixed objects on your chart? Okay. If your fixed objects aren't on your chart, You can't use them. You can take bearings all you want, but they're not going to give you any navigational help. Okay? The use of magnetic bearings to be able to plot a line from a known point. So you know where you are, you can then plot a line using your magnetic compasses. Now, next week we'll go into compasses a lot more heavily, so I'm not going to go into it too heavily now. Okay? You can use multiple bearings to create a position. Okay, like a 3-point fix. There's 1, there's 2, there's 3. During the last Manila Accords of the IMO meetings, there was a bit of a change that came out. All commercial vessels over a certain size must do a visual 3-point fix over a GPS fix. It's now been made maritime law. So if you're on a ship and you're going around Cape Point and you can still see 3 points that give you the ability to do a 3-point fix, that's how you do your fix. The chances of an error when you're writing a bunch of numbers versus the chances of an error when you take 3 bearings and one's incorrect are minuscule. You will immediately see your error in a 3-point fix, not necessarily so when you're using a GPS fix. 3-point fixes are far, far safer. Okay? Bearings don't always line up. Don't worry about it. If you're sailing along like this from A to B across here, you've taken a bearing off that church, you've taken a bearing off that day mark, and you've taken a bearing off the end of that headland. Okay? And they don't line up. Remember, you were moving while you took those bearings. It doesn't matter. You're somewhere in that triangle. That's accurate enough for any navigation. All you do is you put your fix closest to the danger, which means you're moving yourself away from the danger anyway. So you don't have to worry if they don't line up. As I said, put your fix closest to the danger. You've got yourself a fix that you can work from safely. Okay? You can use your depth as well. Very, very useful when going around the coast, very useful when going up to Longabon. Very incredibly useful when going into places like Saldan, Longabon itself, the yacht club. Okay? If you follow a contour within a meter or two either side, you can make sure you're saying, okay, it's getting shallower, let me go off, it's getting deeper, let me come in. Okay? And then you just take one bearing on a fixed point and you've got yourself a fix. Very, very, very useful for coastal navigation. Okay? It's quick to achieve. One bearing takes no time at all. The advantage, of course, is knowing that you're out of danger. You always know that you've got 10 meters of water below you in this case, or 5 meters or whatever you're following. Okay? Can be used for a basic course to follow around a shore. So if you know that the coast is pretty even around a shore, you can follow that and keep yourself out of danger all the time. Next one, transits. I think anybody who's sailed into Longabon Lagoon knows what a transit is, especially at night. There's some perfect lights to line up there. Okay, so you've got 2 lights. In this case, I've just used visual representation. The V and the circle. There we go. Put them in line. You know 100% guaranteed you're on that line. If it's not in line, either way, you're not in transit. You know you're somewhere on that line. You can use another line to get a fix. Transits have 0 chance of error. There's no error in them. Okay, so these lights here, these are the leading lights for the brand new transit lights for the brand new HMS Queen Elizabeth to enter Portsmouth Harbour. So they actually put pillars in the water like that. There's another 3 further offshore, there's another 3 inshore. And you line them up for that, literally for that aircraft carrier to get into Portsmouth Harbour, there is something like 6 foot either side of the entrance for that vessel to get in. But you can get in using transits. Very good navigational aids. Here's another way of using a transit. You know, if you line that headline up and that headland up, and you don't go inside it, you're going nowhere near these rocks or shallows. So you know to tack before that transit lines up. It's a very quick and easy way of keeping yourself out of trouble. A perfect example in Cape Waters is going into Hout Bay when you have to go around Kabonkelberg, and you know there's Vulcan Rock out there. If you line up the radio aerial and the Sentinel, where the Sentinel hits the water, you're on the transit for Vulcan Rock, which means if you keep yourself out of that transit, you know you're going to miss the rock. Okay, a running fix. I'm not going to talk the whole way through it. It can be used, especially up the west coast, where there are very few landmarks between here and Langebaan. You can do, a perfect one is to do off Dustin Island, use the lighthouse there, you do a running fix, and you can end up with a very, very accurate fix on one lighthouse alone. Okay, but it takes time. The advantage is it can be used on a single lighthouse at night. So you can get a good fix on a single lighthouse at night. Okay. Okay, things to be aware of when doing visual fixing. Okay, I've mentioned the maritime law, you need to do a 3-point fix at minimum. Okay, errors show up far, far more easily with GPS fixing. Now people go, oh, GPS is 100% accurate. If you write a bunch of numbers down, okay, sorry, I didn't mean to do that. If you write a bunch of numbers down, the chances are of getting one thing slightly wrong, or the chances you read it slightly wrong here, and you put yourself here instead of here, you could well be putting yourself in danger, especially at night. If you've got a visual fix and you've gone, that's definitely there, that's definitely, okay, I'm definitely out of the way. Visual fixes, I use them all the time, and I think they're a far better system. Okay? It also keeps your navigational ability up. If you keep doing visual fixes, you actually keep pulling a chart out, and you keep practicing, it keeps your abilities top-notch. And you look really cool in front of your crew when you do it. You pull a chart out and a compass. Everyone thinks, hey, geez, my skipper knows what he's up to. Okay, so a little bit of a quiz. Let's have a look, see how we're thinking. Chart datum is the date the chart was written, the lowest astronomical tide, will always show all visible rocks and land on your chart, or is it B and C together? Let's see what these answers start looking like. Getting a lot of B's, not getting many C's. Okay, Leeway can change your course. Is it affected by wind? Is it affected by a wave? Or all of the above? Getting lots of D's there. Lovely. Okay. You're going into Portsmouth Harbour, and the harbour master asks you for your position. You're going to Cape Town Harbour, and the harbour master asks you for your position. What fix would you use? What's the quickest possible fix if you're on the radio to the harbour master? So, chart datum question is both B and C. It is the lowest astronomical tide, yes, 100%. It is also, it will always show all visible rocks and land on your chart. So if you are at the lowest astronomical tide, so in other words, the tide is as low as it is, every rock and piece of land will show on your chart. Tide. If you're not at the lowest astronomical tide, it will still show them on your chart, but it will, you might not be able to see that they're there. Alan, can you just check your video on and just make sure that I'm coming through, because I just had an incoming call.
You're good.
Am I coming through okay, Al?
Video and sound is fine.
Okay, great. Thank you. What I've done, guys, is I'm definitely going on Wi-Fi hotspots, because after my first one, we had a load shedding like as we started. I'm not trusting the Wi-Fi at the moment. Okay, then Leeway can change. Both your course is affected by wind and is affected by waves. So when you take into account Leeway, you might be in very, very light breeze, but in a big swell. That will affect you. Or inversely, might be nice flat water behind Robben Island, but it's a howling, howling, howling breeze. So that can affect you as well. So take into account all the factors that before you try and calculate Leeway. A good tip with Leeway is if you do a couple of DRs, dead reckonings, then you do a couple of plots of what you actually did, you can get a very good idea of what your boat does in Leeway. Okay, and if you're going into a port, the harbor master will know what every single buoy is called. So you can literally go past that buoy and say, I am going past buoy number 4, buoy number 2. Some of them have got names. And you can just say, I am a cable short of X buoy. He will be happy with that. Very happy with that. Okay, satellite-driven depositions. The GPS system, I think we've all heard of it, and please don't tell me I'm speaking to people who've never heard of GPS. It's a bunch of satellites that circle the globe that then do basically a fix to your instrument. Okay? The more satellites you have, the better your fix will be. Okay? The satellites are all in geosynchronous orbit and the Earth moves around them. So it doesn't matter where you are on the planet, okay, your position gets more and more accurate with the number of satellites it's picking up. So it's a 3-point fix or a 4-point fix or a 5, depending on how many. This is a 7, then it'll change to an 8, and then a 7, then a 6. That's basically a vertical 3-point fix. Okay? Different areas of the globe have better reception. Okay. And now if you go to the Arctic, the Antarctic, you start sailing below 40 degrees south and about 60 degrees north, you will find that your GPS reception reduces. You might wait a good half an hour. I don't think it's an issue that we're going to have sailing in out of Cape Town. Okay? The speed of the update on your satellite is not relevant to marine vessel speeds. We just don't go fast enough. It might be relevant to a Boeing 747 doing just under 1,000 k's an hour. It's not relevant for us. We're doing a couple of k's an hour. Okay? Instant information that we get is really useful. And I think most of us use it. Speed over ground, course over ground. We spoke about what those two are, and it's pretty instant, fantastic stuff. Okay? It can be linked in with all your weather information into your systems. Really, really useful. Okay? Most one of these things will calculate all magnetic variations for you. They know what they are, and they'll calculate magnetic variations for you. They will, however, not do deviation. Please note that. But we'll talk about deviation next week. Okay? And we can go on with advantage, etc., etc., etc. But the pitfalls of electronic navigation. The first one is human error. Your Latin long is that. You're just outside Cape Town. You've got no problem, you're safe. You plot that, you're actually on the land, or you're about to hit land. Note the very subtle difference. You're 33, 57, 5, 18, 25, 5. You plot it as 33, 25, 5, 18, 57, 5. That's just a tiny, tiny error, but that puts you on the rocks. Very, very easy mistake. There's no way of double checking an electronic position unless you go and do a visual fix. So it's very easy to confuse numbers, and especially at night. It's when I see all the errors. Okay. Waypoints. Waypoints is basically a list of positions that combine together make up a course for us. We want to go between A and B. We give ourselves a list of positions that we want to go, and we get ourselves a course. Okay? You've got a known position where you're starting from. That's where you're starting your course, probably in port. If not, you're deciding to change course when you're at sea, you get a fix, you've got a starting position. You then make a waypoint list. That's where I want to go first, then there, then there, then there. You'll notice I've each one of them named slightly differently. Waypoint 1, 2, 3, 4. You can name them whatever you want. What is a very good idea is you're going to put them in your GPS. Make sure you name them both the same on your chart as on your GPS. Okay? So you plan where you want to go. You plot your A points as accurately as possible on your chart, because then you can double check against what you put into your computer as well. Okay? I have seen some horrendous errors where waypoint 1 and waypoint 2 are plotted on a nice piece of paper at 2 miles apart, and then you put them on your computer, and waypoint 1 and 2 is 2 cables apart, and 2 and 3 is 3.8 miles apart. Note the symbol, the square with the cross through it. That's the standard symbol for a waypoint. You see that on the chart, it doesn't mean a fix, it's a waypoint. So if you all use the same symbols, you can all understand. Okay? Now remember, waypoints are a guide. They're not, you must go to that spot, you must go to that spot, you must go to that spot. Okay? So here's your hazard. You're creating a route to go around that hazard. In this case, you want to stay north here and then stay east here. Doesn't matter if you're outside it in this case. It would be a problem if you come inside. So waypoints aren't something that you have to actually go. Now, even racing marks, we have them as a waypoint, and it says stay north of waypoint number 2. You can be a long way north of it, it doesn't matter. Racing marks, you don't have to be at the mark. You can go a long way from it and come around if you feel it's right. Course to steers. Course to steer is a little bit more complicated. Okay, what you need, obviously your start and finish points, where you're going to steer from and to. Your tide, the speed and direction of your tide. So what's the speed, the flow, and the direction? Where is it flowing from and to? Your proposed speed, how fast you're going to be traveling at. So, doing a course to steer. There's my DR, I want to do that. Starting there at A, going to B, okay? I.e. this is my COG that I want to achieve, my course over ground, okay? So you plot your tide, okay? There we go. The tide was going to be flowing from the northwest at that speed. You then have to arc your distance off. Now, when I say arc your distance off, you've got to say, in 1 hour at 6 knots, I'm going to do 6 miles. You measure up 6 miles, and you arc it off from the end of your tide. Okay? You can't just draw a line there and say, I'm doing 6 miles. You need to arc it off. Okay? Remember, your measurement comes from your latitude scale, and you start it from the end of your tide to where not basically what your course to steer is, what you want to achieve. So you will be steering that course. You see how the boat's pointing off in a funny direction, but you will be going along the water on that line. This is what we're trying to calculate with course to steer. So you won't necessarily be pointing in the direction that you're going. Okay, so here we looked at it again, original one. Here was our original course to steer planned. That was our tide. We took the end of our tide and we arced it off where the green line is. So that's the distance we're going to cover. Okay. We're going to end up there, steering this course, traveling on that line. Now, this sounds really complicated, guys. It's not. The trick with it is, you see how the tide is pushing us that way? We're steering to compensate for that. So we're actually going further. So if I measure the distance between C and D, it's about, from A, we get that far. Because the tide's helping us, we're going further. It might be the reverse. If the tide's against you, you won't go as far. But this is what we're trying to achieve when we're looking at course to steer. Okay? Now, in Cape Town, we don't get a huge amount of tide. I use it every now and then during springs, but it's not really that relevant. When you start getting to other places in the world where there is massive tidal flow, you really, really need to get these very accurate, because you can end up sailing completely the wrong way. And then if you think you're going to need to add some leeway. Now I'm going to just do a little bit more on leeway now. If we're going downwind, we're going to have minimal leeway. In fact, what leeway we're going to be getting is going to be pushing us towards our destination. If you're going into the wind, you're going to have vastly more leeway. So that's why I say, if required, add leeway. Another little thing, note the markings. The single arrow, that's your course to steer. The double arrow, that's your course over ground. And 3 arrows, that's your tide. That's pretty much universal. If anyone is drawing anything on a chart, those 3 pretty much universally stand. Same as the square with the cross for a waypoint. That's pretty much standard in every single navigational system. So this is what it would kind of look like on your chart. Ignore roughly the purple, but there we go. That's my starting point. That's what I want to achieve. I want to end up here somewhere going around this headland. My tide is pushing me that way. So that's the speed I'm doing. That's my distance. I arc it off. There's my arced off distance. That angle gives me my course to steer. So that's where my boat is pointing. Whoops, sorry, clicked. That's where my boat is pointing to get round that headland. If I point at the headland, I'm going to end up down here somewhere. That's why getting a course to steer with tide is important. Note the arrows again. Heading, course over ground, tide. Same. You're going to cross the English Channel, or you're going to sail a bit of a distance. You can do tide in multiple hours. There's one with just a single tide. Here's one with 5 hours of tide. So I've just done 5 hours of tide, 5 hours of boat speed. 1 hour of tide, 1 hour of boat speed. You can do a number of 1 hour calculations, or you can do 5 hours in one. It makes no difference. Okay, let's have a little bit of a quizzy thing. When plotting a GPS position, is it considered more accurate than a 3-point fix? Yes, no, both are acceptable. The 3-point fix is preferred if possible. So this is a GPS versus getting out there and actually pulling a compass out. Anton's hedging his bets. He's going for multiple answers. Okay, next one. Is my GPS always accurate? So is it yes, no? Depends on where on Earth you are, and depends on my speed. Now remember, I'm talking maritime here. We're not doing a flying course. Okay. When doing my course to steer, where do I get my arced off distance? So the distance you arced off, my latitude scale, my longitude scale, my course over ground, and my course over ground and my tide. That distance that I arc off from my speed. So if I'm going to be doing 6 miles an hour, that's 6 miles. Where do I get that distance from? So when plotting a GPS position, is it considered more accurate than a 3-point fix? A 3-point fix is the preferred if possible. It is always preferred, and even from our points of view on a yacht. If you take 3 bearings and you've made an error on one of them and you plot them, it will be brutally obvious on your plot. You will go out and do it again, and then you'll see that you got it right, which is why commercial vessels over a certain size now have to do them. Okay. People will say a GPS position is more accurate. In maritime terms, it is not considered more accurate. The IMO has said a 3-point fix is the preferred possible fix. However, is my GPS always accurate? Yes, it will be. Doesn't matter where in the world you are and what speed you're doing, it will just update slower. So even if you go into the Arctic regions or the Antarctic regions, it just takes longer to update, but it is accurate. The GPS is now global. Not a problem. You can use it anywhere on the globe. And where do I get my distance for my arc off? It's your latitude scale. Now, I put this question in for a specific reason. Guys, distance is always, always, always latitude. And I keep reiterating this because the number of times I see somebody use a longitude scale because it's easier to use your longitude scale because it just happens to be the way the chart folds. You must unfold it and use latitude scale. It's just a common error, using a longitude scale for distance and speed. Okay, so about time, finishing up. Guys, this is literally, again, just scratching the surface. And I've said in every week, this is not a full course. This is a bit of a general knowledge, share a bit of general knowledge. If you want to do full courses, let me know. We can always arrange that sort of thing. And for the guys who have been talking about Celestial, I am in the process of trying to put something together for you, so we can chat about that as well. Okay, if you do a course in the classroom, you will do loads and loads of these examples. They become second nature to you. We will also do them at sea. Okay, your course to steer will definitely be in your exam if you're writing one, whether it's RYA, whether it's ITC, or whether it's SAS or SAMHSA, it's definitely in there. Okay, your paper chart passage making will be in all of the exams. You will need to be able to do this stuff accurately if you want to do an exam. Okay, and don't panic about it. Practice makes perfect. Okay, as I said it before, if it's worrying you and you are going to write an exam or something, you know, just call or email me. I'm very, very happy to spend some time helping guys. Okay, so before we go back to that one, session 6, we'll talk about the compass, as I said, the applications of variation. Where does variation come from? Remember our compass roses? The awareness of deviation and its causes, and the favorite ones that we have, what sends people off course, and the use of a hand-bearing compass versus a ship's compass. So we'll go through that next week. Okay? Reading, we're going to have a read on variation, give you a bit of ideas before we start. Deviation, okay? And then general compass awareness. I've seen some horrendous errors with compasses. Okay, so, guys, perfect timing, 10:02, time for some questions. Anybody want any questions? Anybody wanting to share or add? Please, guys, come on in.
There was a couple of questions in the chat box there.
Okay, can somebody read them out to me? Somebody who's got the chat box available.
Wavy, there was a question, where's the best place to buy a sextant, a cheaper plastic version?
Online. That's where I get all mine from. Just a word of warning, and you're going to laugh at this one. Do not type into your computer sextant, because you get pages of porn. Type in traditional nautical instrument, because I started getting all sorts of dodgy ads the moment I ordered a sextant.
Great excuse, Wavy.
Oh, that's what you said earlier, Wavy.
No, seriously, I had to actually, it was the weirdest thing. And I was like, well, why am I getting all this dodgy stuff? And then I realized because I typed in the word sex. So anyway, welcome to the internet. But no, I ordered my last one online, and it's done a number of crossings. It's done me good. I can't remember the name of the company. I can check for you though anyway. Other questions?
No, there's just some banter with Pete and Alan as always. But, Pete says Alan's already found something out of spell sextant.
People that should be listening the hardest, you know.
Well done, Wavy. It was really good. Well done.
Okay, thank you, Alan. Like guys, seriously, don't be shy if you want to ask any questions or anything that I've mentioned. If you want to do it outside the forum,